Hey everybody, I'm Mr. Mills, and today we're going to be talking about parent functions and transformations. Now, you might remember from earlier in the year that a parent function is like the simplest function in a family, right? So a linear function, a constant function, a quadratic, a cubic, an absolute value, they all have a parent function of some sort, and it's the most basic function in the family. It's the one that hasn't been messed with at all, no transformations, no translations, no dilations, nothing like that. Just the regular basic function with nothing else, no numbers attached to it at all, right? So specifically, we're going to talk about two parent functions, and those are going to be the quadratic function and the absolute value function. Now I'm going to go ahead and start off by just drawing what the parent function looks like for each of these. So the quadratic function, you might remember, that's the parabola one, right? That's the one that looks like a U, kind of looks like the St. Louis arch, except of course facing upwards instead of downwards, right? So the quadratic function is this U that touches my origin, right at 0, 0, and it just goes upwards. That's the parent function of the quadratic, okay? Now, remember, of course, this could be translated or transformed somehow, right? Like, I could make it skinnier, right? This would be an example of a quadratic as well. It's a little bit skinnier, it's steeper, it goes up faster. It's still a quadratic, it just now has some sort of transformation applied to it. Okay, it might, instead of being, I don't know, still at the origin, it might have moved over to the right and also up 3, right? And so this is still a quadratic function. However, now it's been transformed again in another way, where this time it's been moved to the right, it's moved up, and it also appears to be a little bit wider, right? So it's still a quadratic, however, it has had some transformations applied to it, right? But the idea is it's still in the same family of functions, it's still a quadratic function, okay? And absolute value functions, very similar, where we still have a parent function, and that parent function for an absolute value looks like a V. It looks like a V with the little with the vertex or the point of the V at the origin, at the 0, 0 point, right? And so this would be the parent function of the family of absolute value functions, right? But the same principles apply where we could transform that parent function in some way, shape, or form, right? And so maybe we transform it to where it's now down and to the left, right? And it's still it's still an absolute value function. It's still in the same family. However, now it's been shifted to the left horizontally, and vertically it has been shifted down, right? And so it is still in the same family. It's still an absolute value function, but there has been some sort of transformation applied to it, okay? And just like the quadratic, of course, both of these could be facing downwards, right? Like, even if they're facing down, they are still in the same family of functions. They are still absolute value functions, okay? And so these are all in the same family. They are all quadratic functions. These guys over here, they are all in the same family. They are all absolute value functions. It just, the dashed ones have some sort of transformation, being applied to them, okay? And so that's what I'm going to talk about with some examples here is how to identify what transformations have been applied, and then also maybe given some transformations, how could you write an equation with those characteristics, okay? And to start that, I'm going to first write the general equation of each of these functions, right? And so where are you looking at in the functions to find out if it's been horizontally or vertically translated, or maybe vertically stretched or compressed, okay? And so with the quadratic function, I'm going to start off, I'm going to write, I'll write f of x equals, I'm going to do a times parenthesis x minus h, close that parenthesis, squared, and then plus k. Okay, and this is the generic form of a quadratic function, right? It's the general form, it's the standard form, where x is still our variable, as it usually is in most problems, except now I have these other three letters in here, A, H, and K, and I'm going to call those three letters, I'm going to call them parameters, as they're not variables, but they do affect the graph of the problem, depending on what the values of those three parameters are. Okay? And now, all three of these affect the graph in different ways, and I'll go ahead and write out how they affect the graph. Okay. So, first I have this A out front. That A out front, that is how I can tell if the graph is going to be stretched or if it is going to be compressed. Okay. And it also determines whether the graph is going to be facing upwards or downwards. However, for right now, I'm ignoring that, and I'm not going to give any problems that would affect that, right? Positive or negative. They're all just going to be positive. They will all be facing upwards. Okay, but that A value up front, that determines whether my graph is going to be vertically stretched or vertically compressed, right? And the stretched is where it gets really skinny and it rises steeper and steeper. And the compressed, of course, is where it gets really wide and it rises slower and slower. Okay, and then beyond A, I also have H. And H is what is considered the phase shift. But I usually just say the horizontal shift, horizontal movement, horizontal translations, right? And so this is left or right. Okay, and then another key note with H is that while it moves it left and right, it's kind of weird where H, to me, kind of moves the graph in the opposite direction in which you might think. And I'll even talk about that with this example down here. So opposite. Okay, that's just in my head. And then the last one I have is this K right here. And K stands for covertical, if you didn't know that, right? And so this moves the graph up and down, covertically, up and down. And that is not the opposite way. That's exactly what you would think. If K is positive, then it shifts the graph up. And if it's negative, it shifts the graph down, right? Okay. So this is the generic form of a quadratic function, or the general form, the standard form, whatever you want to call it. Where A, H, and K are all parameters that affect the graph in some way. They transform the graph by moving it up or down, left or right, or they maybe stretch it or compress it. Sorry. Okay, and then next I have my absolute value function. Now, the absolute value function, the standard form of it is very, very similar. The only thing is, instead of having the square in there, we have absolute value bars. Okay, so I'm going to start off with f of x, and that will equal a times absolute value of x minus h, and then close the absolute value, and then plus k. Okay, and so now all three of these parameters actually affect the graph in the same way, where a is the parameter that affects whether it's being stretched or compressed, so really whether it's getting skinny or wider. All right, so this is stretched or compressed. And then again, it does affect whether it's facing upwards or downwards. But for the sake of this, we're just going to keep A as positive, meaning the graph will always go upwards, not downwards. Okay. And then I have H here, and H again is the phase shift, but I just call it the horizontal shift or horizontal translations. Right. So this determines whether it's going to go left or right. And then again, H here, I usually think of it as it goes in the opposite direction to which you would probably think, right? So opposite. Opposite, okay. And then lastly, again, we have K for covertical. So that determines whether it goes up or down. Okay, and so both of these functions you can see are super similar. They even look pretty close to each other, right? Like this is more of a U and that one's more of a V, but they still, they kind of mirror each side of each other, right? And so the left side over here is basically the same as the right side, however, it's just kind of flipped, it's being reflected, right? But the parameters all work the same for both functions, right? So I have a couple examples here of, first we're gonna state the transformations by being given this equation right here. And then secondly, while you are given these transformations, we will write the equation using those characteristics, okay? So first, I'm gonna start with this guy. So state the transformations of y equals 2 times x plus 1 squared minus 7. Okay, well, first of all, I gotta recognize, is this an absolute value function or is it a quadratic function? And well, the number one way, and really the only way to determine that, is just look, is there a square or is there not a square, right? And so here I can see there is a square, there's no absolute value bars, so right away I know this must be a quadratic function. Quadratic function. And I'll just write quadratic. Okay. And then for my horizontal translation, I'm trying to see is it going left or right, and then how many units. So for horizontal, that's left or right. So for my horizontal, I'm looking at my h value here, right? So I'm looking at this plus 1. And this is where it gets kind of weird. Because it's positive 1, most of us would probably think, hey, it's probably going to the right. However, like I said, the h value, the h does the opposite of what you would think. So this plus 1 actually means it goes to the left 1. I'll just put left 1 unit. Okay. And then my vertical translation, that's why I'm looking at this k value at the end for covertical, this minus 7 right here. So since it's minus 7, I'm thinking, hey, it must go down 7 units. So down 7 units. Okay. And then lastly, is this function being stretched or compressed? Well, this value out front is bigger than 1, so I know this is being stretched. And what's the factor it's being stretched by? Well, it's being stretched by a factor of 2 out front. So by a factor of 2. Stretched by a factor of 2. Okay. So I was able to tell all 4 of these characteristics just by looking at this equation right here. Okay, and then lastly, instead of writing the translations out, now I'm given the translations and I'm going to write out the equation that meets these characteristics of the graph. Okay, so first of all, my parent function is an absolute value function. So since it's an absolute value, I know that I'm kind of looking at this guy right here. So I'm going to start by, I'll do y equals, and then I'm going to need to eventually have an a, h, and k in there. But for right now, I'm just going to kind of leave them blank, and I'll fill them in as I go along. So we'll have my absolute values, and then I'll just start with that for right now, right? But I have my absolute values in there because it says the parent function is the absolute value. And then let's think. My horizontal translation here is it's going right 4 units, right? And so since it's going to the right 4 units, I'm thinking, is that a, h, or k? Well, we already said that h is the parameter that determines whether it's going left or right. Okay, so I know my h value is going to be 4. And then the question is it going to be plus 4 or minus 4? Well, like I've said, the h value is the one that does the opposite of what you would probably think. So since it's going to the right 4 units, you'd probably think it would be plus 4. However, it's doing the opposite, so it actually would be minus 4. So minus 4. Okay, and then I have my vertical translation here. My vertical translation is going down 3 units. So again, remember k at the end here, that's the vertical shift. It's going down 3 units, so -3. Okay, and then lastly, it's being stretched by a factor of 5. So since it's being stretched by a factor of 5, that means out front, my A value is going to be 5. Okay, and so both of these problems, super similar to each other, but it's ironic, they're actually like opposites of each other, right? And so I'm able to tell all this information based upon just what I was given right here. I was able to write an equation. Okay, and that's gonna be all for today. Thank you for watching.